All right, so with example 5, we can simplify it to what is listed just above, and now start the second step of our 7-step process. So after we simplify, we can find a y-intercept. The y-intercept in this case, the numerator just becomes, plug in 0 for x, numerator becomes 0, so it doesn't matter what the denominator is. All right, that means that the y-intercept will be 0. So if we plug in 0 for x, the output is 0. So we will have a point at 0, 0. Okay. What's up? Plug in 0 for x. Okay. From there, we can then find the x-intercept by setting the numerator equal to 0. So if we set the numerator equal to 0, we do have two separate factors there. All right. So we have x and x minus 1. So if we set both of those equal to 0, we have x equals 0, which means we have an x-intercept at 0, which makes sense because that's where we have our y-intercept, right? Okay. And then if we set x minus 1 equal to 0, we'll get x equals 1. So there'll be an x-intercept at 1, 0 as well. Okay. Talk about that in a second. Okay. From there, we can find the vertical asymptote. So the vertical asymptote, we can set x plus 1 equal to 0. That gives us x equals -1. Okay. And the unique aspect about this graph is going to occur when we look at the degree of the numerator and the degree of the denominator. Now this will be different. So the degree of the numerator is equal to 2. We often call that n. So we say n equals 2. The degree of the denominator is equal to 1. So in this case, we often call that m. So in this case, n is greater than m, which means we will have a slant asymptote. Okay. To find the slant asymptote, we actually use division. All right. In this case, we can utilize synthetic division. So what we're going to actually do, divide this. So we're going to do x squared x divided by x plus 1. Okay. So for the slant asymptote, we will perform some synthetic division. This is our divisor. And remember, if it's listed as a binomial like that, within synthetic division, we will use the opposite of the constant term. So we'll use -1 here. All right. And then working through this, we list out the coefficients of our dividends. So the coefficient of x squared is 1. The coefficient of the minus x would be -1. And then the constant term is technically 0. Although you'll see we don't really even need that in a second. So rolling through the process of synthetic, we always bring this down first. And then remember, it's just multiplication and addition. So you're going to multiply -1 times 1. That gives us -1. There. And then -1 plus -1 is -2. You can actually stop there because if you remember, the last term, which would go here for synthetic division, is always the remainder. And we actually don't need what the remainder is because this already gives us enough information right here to write an equation of a line, because a slant asymptote will have a slope and a y-intercept. So the result of this is just an equation of y equals the 1x minus 2, or y equals x minus 2. Okay. So the y-intercept would be -2. and the slope is 1. So that would just be up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And that gives us enough points to plot the slant asymptote. I think these other points we have in color. Yeah. You bring down the 1, multiply those two. That gives us there. So -1 times 1 is -1, and add down. So what's up? This one? It's always the opposite of the constant. Okay. Yeah, so I started at -2, and then up 1 to the right 1. Okay. So that creates the structure that we have on our graph, and again, we can look at our picture and see if it matches. If we go to y equals, again, I would put that original function in there, numerator and denominator in their own set of parentheses, and if we look at the graph, it looks pretty similar. Calculator's not working, but it did look similar. So we can get some additional points that exist on that graph. We already have 2, and if we looked at that, the picture of the graph, you can do that on your calculator. It looked like the graph came down like this, and then it approaches slant asymptote here, and then the other section that it existed in was this one down here, which we don't have a great picture of. Let's see if I can get this to work. So if we connect a couple dots there, our picture will look like this. We have enough points that exist in that section there. Okay, and then we would need to get a point down here as well in this area, this lower section, because that's where it exists. So what we can do is just we can plug some values in by hand, or you can look at the table on your calculator. Did anyone type that into their calculator? Anyone do that? No? You did? Okay. So if we like plug in -2, if you go to your table, what is a point at -2? Okay, so we got a point at -2, -6, which is obviously off of the graph. Okay, so it'll be down there, and that portion of the graph looks something like that. Okay, so on a tester quiz, I would certainly give you a face to make sure that your graph fit. That one, obviously not ideal. On your, it does say relative max and relative min. We need to be able to utilize the calculator to do that. So since my calculator is not working very well right now, I can't really show you that, but the relative min and max would basically be what we need to use to find domain and range. So it would be like, this would be like the relative min right here. And then the relative max would be somewhere around there. And we've done that. The way that you do it is you hit second and the trace key. That takes you to that calculate menu, and remember where it says max and min, and you have that fun conversation with your calculator, right? Left bound, right bound, yes. Okay, so that's how you can find those relative maxes and mins. Okay. The domain we can find pretty easily. That would be all reals. X cannot equal -1. Okay. All right, just that. Single restriction. The range is what we would need the relative max and mins for, because there's a gap here between those. But we'll talk more about that tomorrow. Okay. Cool.